Hey everyone, welcome to this explainer. Today, we're literally unlocking the secret rules that govern real-world relationships. We're talking about the absolute fundamentals of algebraic variation and proportion. Let's get right into it. Okay, let's dive into this with a question that's going to seem totally random. What do buying apples at the grocery store and the intensity of light shining from a lamp actually have in common? I mean, on the surface, absolutely nothing, right? But in the mathematical universe, they're tightly connected by these invisible strings called variation. And once you understand how to read these strings, you can predict exactly how one thing's going to behave when another thing changes. Here is our quick roadmap for the explainer. First, unlocking mathematical relationships. Then moving together and moving apart. Power and joint variation. Variation in the real world. Some common traps to avoid. And finally, a quick check of your understanding. We're going to build an incredible mental cheat sheet by the end of this journey. Section 1. Unlocking mathematical relationships, the secret DNA. Because we aren't just looking at math here, we're looking at how the entire world connects. So, what is variation? Basically, it describes exactly how one quantity changes when another quantity changes, all connected by a specific mathematical rule. When two things are locked together by this rule, we say they vary with each other. As we go through this, I really want you to think of yourself as a pattern hunter. Your whole job is just to figure out the rule that binds the changing quantities together. Section 2. Moving together and moving apart, core relationships. Let's look at the two most fundamental types of relationships you'll encounter. Now, what's really interesting here is contrasting these two dynamics. Think of direct variation as moving perfectly in sync, kind of like dancers. As one quantity increases, the other increases right in step. Like, if you buy more apples, your cost goes up. The formula here is simply y equals k times x. But then, on the other side, we have inverse variation. And this is essentially a balancing act on a seesaw. As one quantity goes up, the other absolutely must go down to compensate. Their product stays exactly the same. The formula for this is y equals k divided by x, which, by the way, you can also write as x times y equals k. Okay, so the absolutely crucial point in all of this is that little letter k. We call this the constant of proportionality. It's the steady, unchanging value that perfectly connects your variables. I want you to literally lock this phrase into your brain right now. Find k, find the answer. Honestly, it doesn't matter how complicated a variation problem looks, because k is the secret key that unlocks every single equation we're looking at today. Let's see this in action with a simple direct variation problem. Imagine we're told that y varies directly as x. We know that y is 28 when x is 7, and our goal is to find y when x is 12. Well, think about step 1. Find k. We take our template, y equals kx, and just plug in our knowns. 28 equals 7 times k. Divide both sides by 7, and boom, we discover that our secret key, k, is 4. Step 2. Form the equation. We just replace that generic k with our newly found key, giving us y equals 4x. And step 3, substitute. Now we simply plug in our new x value of 12. Y equals 4 times 12, which gives us 48. See? Beautiful, logical, and super straightforward. Now, let's visualize inverse variation. Imagine you're driving on a 240-kilometer journey. The time it takes you to arrive is equal to the distance divided by your speed. So, obviously, as your speed increases, your travel time decreases. They're moving in opposite directions. If you map this out on a graph, it wouldn't be a straight line through the origin like direct variation. Instead, it creates this sweeping, curved graph called a hyperbola that never quite touches the x or y axis. Moving on to section 3, power and joint variation, scaling up, because sometimes relationships scale up and get a bit more complex. Yeah, sometimes a simple one-to-one relationship just isn't enough. With power variation, a quantity varies as a power of another. This is exponential impact, folks. You might see y equals kx squared, or maybe x cubed. A tiny change in x creates a massive change in y. And then we have joint variation. This is essentially a team effort. Instead of relying on just x, y depends on more than one variable pulling the strings simultaneously. This is represented as y equals k times x times z. All right, section 4, variation in the real world, the math in reality. Let's prove these formulas aren't just for math tests. Think about these real-world proofs for a second. The area of a circle varies directly as the square of its radius. That is power variation in a nutshell. The volume of a cube varies as the cube of its side length. If you're traveling at a constant speed, the distance you cover varies directly with time.
And this brilliantly illustrates our balancing act from earlier, Boyle's law in physics. The pressure of a gas varies inversely with its volume. So if you squeeze a gas into a smaller volume, the pressure absolutely skyrockets. The math on the page perfectly matches the physics in the lab.
Section 5. Common traps to avoid. The survival guide. Consider me your insider giving you the cheat codes right now. Okay, listen to these warnings carefully. First off, never use addition when finding your constant. Proportionality is all about multiplication and division, period. Second, please do not fall for the classic trap of writing y divided by x equals k for an inverse variation. That is a trap. Inverse variation means their product is constant, so it's x times y equals k. Third, just because a graph is a straight line doesn't mean it's direct variation. An equation like y equals 3x plus 2 shifts the line up. For true direct variation, the line absolutely must pass perfectly through the origin at 0, 0. And lastly, when dealing with area or volume, do not forget to actually square or cube your values in power variation. I know it sounds obvious, but in the heat of a problem, it is so easily forgotten. Section 6. Check your understanding. The final test. It's time to actively apply what you've just learned. But before the questions, take a quick mental snapshot of this summary. This is your ultimate cheat sheet summarizing the source material. We've got direct, inverse, square, cube, and joint variations right alongside their proper equations. And remember our golden rule one last time before we begin. Find k, find the answer. Okay, let's do this. Here is your first rapid-fire question. Read it carefully. If y varies directly as x and y is 20 when x is 4, what is y when x is 9? Take a second. Mentally calculate k first. We know y equals k times x, right? So 20 equals k times 4. Have you got k? Okay, now multiply it by 9. The answer is 45. Did you get it? Our constant k was 5, so substituting that back in, y equals 5 times 9, which gives us 45. Honestly, excellent work if you nail that. Let's try an inverse one now. Question 2. If y varies inversely as x and y is 6 when x is 5, find y when x is 10. Now remember the survival guide. For inverse variation, you multiply to find k because the product is constant. So what is 6 times 5? That's your k. Now take that k and apply it when x is 10. And the answer is 3. Since x times y equals k, 6 times 5 gave us a constant of 30. To find our new y, we take 30 and divide it by our new x of 10, giving us 3. Did you notice how as x went up from 5 to 10, y went down from 6 to 3? That is that balancing act in perfect motion. Which brings us to the end of our journey. You now know exactly how to decipher the mathematical strings that tie quantities together. But I want to leave you with a final, slightly provocative thought. Now that you know the secret, where will you spot the invisible rules of variation in your world today? Are you going to notice direct variation at the grocery checkout? Or maybe spot inverse variation while adjusting your driving speed? Keep those pattern-hunting eyes wide open. Thanks for learning with me on this explainer, and I absolutely cannot wait to dive into our next topic together.